What's up, guys? This is Mr. O'Brien, starting off with part one of the atomic number and isotope, section 1C, and this information will be found on section 4.3 of your textbook. Now, the goal for this quick and short lecture is to understand this idea, atomic number, and what it means, right? So you find the term right here on the right-hand side, which atomic number means the number of protons in any atom. So what makes atoms of one element different from atoms of another? It is the atomic number. It's this number on top. Take a look at the examples I provide you here, carbon and nitrogen. I find these examples fascinating because what separates them on the periodic table is just one number, 6 and 7. One proton essentially changes something that's in your pencil lead, like a soft solid, into a gas that's 80% of the air that you breathe. One proton. One proton in that nucleus changes. And this idea of drastic changes from one proton to the next is visible all throughout that entire periodic table. That periodic table has these elements based on that atomic number. Now, if we move on, where can we find the atomic number? Well, as you already seen, the atomic number is found on top of the element symbol in a periodic square. That number is typically found above, and it also can determine where the element sits on the periodic table. So, for instance, if I had a periodic table, something like this, excuse my poor drawing here, you'll notice that the element number 1 is always on the top left-hand corner. And say, I don't know, an element with like 80 protons is going to sit somewhere south of the periodic table. So the position of the element or of the atomic number really tells you where the element's at on that periodic table. So what else does the atomic number tell you? The atomic number also tells you, as you should know, the number of number of electrons in any atom. In any atom. Now let's pause for a second. I want you to think about this question. Do you remember why the atomic number tells you the number of electrons in an atom? Or if you don't not like this word, what about substituting for protons? Do you know why the number of protons is the same number as the number of electrons? Think about it. If you have a hard time, hit me up or wait till the next slide. You might get the answer there. So take a look at this periodic table. If you notice the periodic table, there's some sort of organizations that I want you to take a look at. So you can pause now. If you look at the periodic table, the number of protons which sits on top is shown. And as you go from left to right across the periodic table, the number increases by 1 consistently all across that periodic table. The key word here is constant, right? Now, you might be wondering, well, Mr. Bryan, there's a problem here at 5771. It jumps by a whole bunch. Well, those whole bunch, those 14 is actually found here, and they do increase by 1 proton. Now, I'm not going to go too deep as to why these rows are off the periodic table, but just to give you a couple of things, that these are rare elements, very rare elements that are found on Earth. And those rare elements are extremely unique. They have really unique properties that differentiate, that are way different from any of these elements found above. If you were to get a periodic table and look at it at a side view, you would imagine these being below the periodic table. And so hence when you get to, like, say, barium, you would count, all right, 56, and now we have the 57 down here, 58, so on, so on, so on. And as you get to 71, then we want to go back up to 72, then you'd count back up. And then this one sits even further south of that periodic table below, and then you'd have to count these numbers and then come right back up that way. So it's quite interesting of how the periodic table is organized. Now, another group of students may seem to see, hey, Brian, there's another way the periodic table is organized. Look at the mass. The mass increased by, they all increase as you go from left to right. Now, that could be true, but this is true. Keyword here is generally. Now, why do I say generally and not constant? Because there's some areas on this periodic table, like this spot right here, in which the atomic mass, the mass of an atom, or as you may know, the molar mass, actually will drop. So here it's 55.8, then it goes 58.9, but then it drops to 58.6. So it drops. Here's another example. 127.6, 126.9. It drops as you go this way. So there's a bunch of different areas on the periodic table where the mass, although it may look organized, the periodic table clearly does not organize based on some general patterns, but rather than a constant pattern as we see the protons. Moving on. So let's think about how we can use the atomic number to identify the elements. So look at this example that I provided here for lead. So lead contains 82 as the atomic number above. Now this number 82 also recognizes the number of protons. And how many electrons do we have is the question. Well, if we know that the atom is neutral, right, which means that it has no charge, your protons, which are positive, has to be the same amount of electrons, which are negative, to cancel out. And so in this case, the answer will be 82, right? So try these two examples out, and when you're done, hit me up at tutorials to see if you got the right answers. Thanks.